Welcome back to part 2. We just rounded up metals for science. Now let's take a look at non-metals. Let's quickly take a look at non-metals, part 2 of this chapter 8. So we said non-metals. Non-metals, they are gases at room temperature. They are gas. Most of them, they are gases at room temperature. They are gases. Most of them, they are gases at room temperature. Most non-metals are also pure conductors of electricity and heat. Most non-metals, they are also poor conductors. They are what? Poor conductors of heat and electricity, meaning they are isolators. Poor conductors. Most non-metals are poor conductors of heat and of electricity, meaning you can call them insulators. You can call them, most non-metals, you can call them insulators. Okay? Most non-metals can be called insulators. Okay, that's that for that. Now let's quickly move ahead. Now, those that are not gases, they're usually brittle. That's, they break easily. They're dull. They're not shiny. Okay? The ones that are not gases, they are what? They are brittle. Meaning they can break easily. Brittle. So most non-metals that are not even gases, they break easily. They are dull also. Non-metals are dull. These are all properties of non-metals that we are describing. They are dull, meaning they are not shiny like metals. You remember, metals are shiny substances. These ones are dull. They are not shiny. Okay, they are not shiny. They are brittle. They can break easily. So when we say brittle, means they can break easily. They can break easily. Non-metals that are not even gases can break easily. They can break easily. They are not strong. Okay? The ones that are not gases, they can break easily. And then they are dull, meaning they are not shiny. Remember, metals are shiny. Metals are shiny. But non-metals, they are not shiny. They are dull, actually. They are not shiny, they are dull. Is that okay? Now let's take a look at the first of the big. Let's take a look at the first of the big non-metals called the carbon. Carbon. Okay, this is one element that is a non-metal. One big element that is a non-metal. Carbon is one of the most important elements on Earth, right? One of the most important elements on Earth. You know, it's found in the whole of organic chemistry in hydrocarbon. Okay, it's found as hydrocarbon. They combine with hydrogen to form hydrocarbon. It's found in petroleum. In fact, diamond is from here and is an allotrope of carbon. Graphite from your pencil is an allotrope of carbon. Although it's not a metal, it's one of the very important elements on Earth. It's used for making electrodes in electrolysis process. It's found in our petrol, gas, and all of these things. It's found in carbon dioxide. It's found in glucose, the carbohydrate we eat. So it's so important. Carbon is so important. And in fact, is one of the most important elements on Earth. It's one of the most important elements found on Earth. And it's present in all the living things. Carbon is found in all living things. You can see how important it is. Found in all living things. In all living things. So it tells you how important it is. Imagine your glucose, carbon is there. Even in the gases that pollute the environment, like carbon monoxide, carbon dioxide, is there. In our body, is there. It's in everything. It's in our food. It's in everywhere. It's in our petrol, our fuel for. Excuse me. It's found in alcohol. Remember, ethanol is the simplest alcohol. C2H5 H5OH. This is your alcohol, ethanol. You can see carbon is there. Okay. If you look at your glucose, C66H12 66H12O6, your glucose, carbon is there. If you look at your carbon dioxide, the gas you breathe out, carbon is there. If you look at your carbon monoxide, carbon is there. So it's found in so many things. Okay, that it's found in all living things as well. So it's super important. It's found, in fact, it's the basis of organic chemistry. If you heard of organic chemistry, the alkane family, alkaline, carboxylic acids, okay, organic chemistry, the entire polymerization, all of this, plastic, nylon, all of this carbon is found there. So you can see, despite it's a non-metal, it's super important. It's found in our food, in our carbohydrate, it's found in our fatty food, in our carbohydrate, it's found in protein food. So it's everything that comprises the organic chemistry. It's so important. It's super important. So you cannot ignore this. Okay? So organic chemistry, the study of organic chemistry is the study of carbon compounds. It's the study of carbon and its compounds. Okay, so that's that for that. In fact, we have two forms of carbon. One is called the diamond. We have two forms. So when we say carbon, we have two forms of it. Or you can use the word allotropes. We have two allotropes of carbon, or two forms of carbon. One is diamond. You've heard of diamond, and the other one is graphite. Okay, so one form of carbon is diamond. Okay, is diamond, which do not conduct electricity, and another form of carbon is graphite, which can conduct electricity. Another form of carbon is graphite. Another form of carbon is graphite. So we have two forms of carbon, the diamond and the graphite. These are the two forms of carbon that we have. And if in fact the lumps of coal, coal also have what we call carbon. Coal contains a lot of carbon. Coal for driving locomotive, for driving train, okay, is made up of carbon. For driving cane is made up of carbon. Sugar cane is made up of carbon. So many things is made up of carbon. Okay, so carbon is very important element, non-metal, that is one of the most important thing on earth, right? Diamonds are the hardest natural substance in the world, and they have a very high refractive index. Diamonds are the hardest natural substance on earth. Hardest natural substance. Despite they are not metals, they are the hardest natural substance. Hardest natural substance on earth. Despite they are not metals. They are non-metals. They are a form of carbon. Okay? And they have very high refractive index. Diamond have very high refractive index. You study refractive index in physics. Okay? In physics. Diamond have very high refractive index. Have very high refractive index. Okay, so You can see diamond, high refractive index means they can bend and reflect light so easily, and they sparkles. Graphite is dull and soft, and it's a gray substance that is used to make pencil leads. Graphite is used for making pencil lead. It's dull. Graphite is dull. It's also soft. In fact, one of the softest. Soft. It's dull. It's soft. And it's used for making pencil lead. Graphite is used for making pencil lead. Pencil lead. Okay? Graphite is used for making pencil lead. Okay, so that's what graphite is. Another form of carbon is used for. Where diamond is hardest, is sparkles. This one sparkles. Where you say sparkles, it's the hardest, has very high refractive index. This one is soft, is dull. This one is shiny, diamond is shiny. While this graphite is dull. Okay? We say this one is shiny, right? Shiny. Or you can say sparkles. You can say sparkles. Diamond sparkles. And a form of carbon is sparkles, right? Why this one is dull, graphite is dull, is soft, and it's used for making pencil lead. So these are the form of these two forms, diamond and graphite. So we can look at their shape. The shape of graphite is kind of, it's kind of like this. Okay, this is graphite. Sorry, this is diamond. It's kind of like this. It's kind of like this.
Green part actually.
Okay. Okay, the graphite is kind of like, the diamond is kind of like this. This is the structure of diamond. Okay, this is the structure of diamond. You can look this up. Your text. Okay, this is diamond. But graphite is different. Now the structure of graphite is different. For graphite, it forms something like
a bus.
Okay, for graphite, it forms something like this. Form something like this, and then this goes this way as well. Okay, so then it goes down. This is the structure of graphite. Then it has another one here, graphite. Okay, why they are soft? Because the bond here is weak. We'll talk about that. The bond here is weak, although the bond here is strong, but the bond here is weak. Yeah. Okay, we use a different color to show the weak bond. The bonds here are strong, while the ones here are weak. Let's use a green color to show the weak bond. The bonds here are weak. Okay, the strong one is, in this case I'm using red. These ones are weak bond. This one, they're weak bond. These ones are weak bond for graphite. While the bonds here are strong. This one you can say strong. Strong here. By connecting the top to bottom, strong here also. But the bond here, they are weak. Weak bond. They're called weak bond. So that's why it's soft. That's why pencil lead is soft. This is for graphite. This is for graphite. This is for graphite. This is for graphite. Okay, why this for diamond? Okay, so that's that for that. Let's move on. Let's go to the next one, silicon. Another non-metal called the silicon. The silicons are like semiconductors. Silicon. Okay. Now, silicon is another important non-metal element. Silicon does not react easily with other substances, and it is used to make the small processor chip that is found in a computer. It's used for making the processor chip that is found in the computer. Is that okay? Silicon is used for making processor chip, okay? For making processor chip that is found in our computer by Intel. One of the manufacturer is Intel Corporation. Okay, they use for making processor chip. Silicon is a semiconductor, but it's also considered a non-metal. They use for making processor chips that are found in our computers, in our phones, in our digital systems. Is that okay? Even though it's a non-metal, silicon is able to conduct electricity under certain conditions, just like graphite. Under certain conditions, graphite can conduct electricity. Under certain condition, silicon is also able to conduct electricity. Okay? When it's in the right condition, silicon is able to conduct electricity. For this reason, silicon is called a semiconductor. So it can be called semiconductor. Why? Under good condition, it's able to conduct electricity. Yeah. It's very hard. Okay? Its structure is like that of diamond. The structure is like that of diamond. Okay, now let's go to non-metal gases. Now we've talked about the solid, the hard ones. Let's go to non-metal gases. Non-metal gases. Non-metal gases. Now, the non-metal gases are essentials for life as well. For this life, the non-metal gases are very, very important. They are very, very important for our existence, right? They are very important to life. They are important to this planet. Like you've heard of oxygen gas, hydrogen gas. All these gases, they are very important part of this life. If they no longer exist, then we are in trouble, right? Some of the important gases are hydrogen, helium, argon, neon, nitrogen, and oxygen. So, some of them are hydrogen, H, capital H, okay? Some of the non-important gases are hydrogen, okay? Oxygen, helium, neon. You know neon, I'm writing their symbols, okay? Neon is Ne. Neon, oxygen, hydrogen, neon, helium. Okay, I mean the gases. Carbon part of it. Okay, so we have hydrogen, we have neon, we have oxygen, we have helium, we have nitrogen, N. Okay, all these are non-metal gases. These are all non-metal gases. Now let's begin to look at them one after the other. Let's start with hydrogen. What kind of gas is hydrogen gas? So hydrogen is the lightest element and the lightest gas. So we can just use the lightest. Hydrogen is the lightest gas. Hydrogen is what? The lightest gas. It's very light. So hydrogen is the lightest gas. We also use it as fuel. We use hydrogen as fuel. You can use the process of electrolysis. You react hydrogen with oxygen to produce energy to drive your cars. Now we use hydrogen. Nowadays, for countries that don't have crude oil or petroleum, they develop the hydrogen energy for driving cars. Okay? So hydrogen is the lightest gas and can be used as fuel. Now a room full of hydrogen would weigh about just 1 kg only. So if you take your room and fill it up with hydrogen, it will only weigh about 1 kg only. It shows how light hydrogen gas is. Hydrogen is plentiful on Earth. It's very plenty on this our planet Earth, but it's normally found in combination with other elements. Most of the time, hydrogen is found in combination with other elements. You know, it reacts with oxygen to form water, and also with oxygen to form hydrogen peroxide. So this is water. It's in a compound with another element called oxygen. So it's found in combination with other elements in compound. Hydrogen is found in combination with other elements in compound, like hydrogen chloride gas. Like hydrogen chloride gas is combination of hydrogen and chlorine. Okay, it's combination of hydrogen and chlorine. It's found in combination with most of other elements, and pure hydrogen is only found in small quantity in the places of the ground and in tiny amount in the air. Pure hydrogen is in tiny amount in the air and in some places on the ground. So hydrogen is very reactive, very, very reactive. This gas, hydrogen gas, is very reactive. Very what? Reactive. Hydrogen gas is very, very reactive. Hydrogen gas is very, very reactive. It's highly flammable. It's highly flammable and it can be explosive. Highly flammable. Not just flammable, it's highly flammable. It's highly flammable. And it can be explosive. And it can be explosive. So hydrogen gas is explosive. So you have to be careful when you deal with it, when you handling it, when you using it in the laboratory. You have to be very careful because it's very explosive, so that you don't burn down the science lab or the chemistry lab. Okay? So you have to be careful. Now let's go to another gas called the helium. Let's talk about another gas. Let's talk about another gas called the helium. Let's select a different color for helium. Let's talk about another gas called the helium. He. The symbol is He. Helium. Okay? Helium is the second lightest gas. Second lightest. After hydrogen is next to it. Second lightest gas. Helium is the second lightest gas. Helium is the second lightest gas. Is that okay? And it's called an inert gas because it's not flammable at all. It's inert gas. So another quality is that we call it a inert gas. And it is complete is out the octet rule. Inert gas. Not flammable.
-135 plus 135 reactor.
Not flammable. We'll soon finish, okay? Not flammable. Not flammable. Is that okay? And then let's go to the next one, argon and neon. They are both inert gases. Argon and neon. They are inert gases just like helium. They are both inert gases, and for this reason they can be used in lighting system. The argon and neon can be used what? In lighting system. In our electrical lighting system, we use argon and neon. They are inert gases, and because of that, they can be used for lighting system. Is that okay? Bulbs. Okay, now let's move on to the last one, hydrogen and oxygen gases. I think that will be our last one. Hydrogen and oxygen gases. Nitrogen, sorry, we'll dealt with hydrogen. Nitrogen and oxygen gases. Quickly, let's take a look at this one. Air contains 78% of nitrogen, you know, right? The composition of air is a mixture of gases. Air is a mixture of gases. 78% of it is nitrogen. Right? Number one, nitrogen. Air contains about 78% of nitrogen. The whole air that you see around us contains 78% of nitrogen. 78%. And it contains oxygen. Let me write the symbol. About 20 to 21% of oxygen. About 20 to 21% of oxygen. And it contains carbon dioxide. It contains about 0.04% of carbon dioxide and 1% of other rare gases. Rare gases or noble gases. It contains about 1% of this. So you can see nitrogen is a lot in our air, in the atmosphere. Yeah. So nitrogen is 78% in the air, and about 21% of oxygen. Both gases, they are colorless and they are tasteless. Both of these gases, they are what? Colorless and tasteless. They are colorless. Both of these two gases, nitrogen is colorless, oxygen is also colorless. They are also tasteless. Both of them, they don't taste. They are tasteless. If you taste it, they are tasteless. They don't say, oh, it's sweet, or it's sour, or it's bitter. No. They're colorless and they're tasteless. Both of the gases. And they have no smell. No smell. Oxygen does not smell. Nitrogen does not smell. No smell. Okay? These two gases, they don't have smell. Nitrogen and oxygen. They're colorless, they're odorless, they're tasteless, they have no smell. Right? Now, oxygen is very essential for our life processes because oxygen joins with other chemicals in the cells to provide the energy that is needed for our life metabolic processes or for our respiration processes. Oxygen combines with other chemicals in our body for respiration to be able to take place. Is that okay? Now, let's take a look at the properties of nitrogen and properties of oxygen. Nitrogen is non-flammable. One of the properties of nitrogen is that it's not flammable, meaning it does not burn so intensely. Or does it support burning? Okay, it's not flammable. Things will not burn in nitrogen. If you put anything in nitrogen, it will not burn. That's the meaning of non-flammable. Oxygen is strongly support combustion. So things burn in oxygen. So number one differences or number one property. Oxygen, things burn in oxygen. Oxygen is supports combustion. Nitrogen does not support combustion. Number 2, nitrogen will form compound biologically at high temperature and with the aid of catalysts at lower temperature. Oxygen combines with most elements. In the case of oxygen, it combines with most elements and is a component of many organic compounds. There are another difference for nitrogen, where nitrogen combine with oxygen to form nitrate. Nitrogen combine with oxygen to form nitrate, while oxygen is an oxidizing agent. Oxygen is reactive and can lead to the corrosion of metals. Oxygen is reactive and can lead to corrosion of metal. Can make metal to corrode.
Rust?
Yes, can make metal to rust. Okay? Oxygen is also an oxidizing agent. This means that it removes electrons from other substances and produce heat in the process. Oxygen combined with all elements except fluorine and noble gases, the group 8 in the periodic table, which are non-reactive. The group 8, they already complete their utmost share of electron 8, so they don't react. So only that and fluorine, that oxygen do not react with. Every other oxygen reacts with it. Okay, so that's the end of our today's class. Thank you very much. Thank you for joining.